Hi everyone, this is Dhanas Sigran, Assistant Professor, Department of Electronics and Communication Engineering, KS Rangasamy College of Technology. Today, I'm going to deliver about addressing modes of 8085. So these are the outlines of today's topic and addressing modes of 8085, direct addressing mode, register addressing mode, register indirect addressing mode, and immediate addressing mode and implied addressing mode. So before going to the addressing mode, we should know about what is addressing mode. So addressing mode in microprocessor defines the way in which the operand data is specified for an instruction. So it determines how the data is accessed from the memory or register and how it is operated upon. The various addressing modes allows for flexibility in how instruction interact with the data, making it possible to optimize performance, minimize memory usage, and reduce code complexity. So uh, these are the factors we have to consider for choosing the addressing modes and choosing the instruction for creating a program. So we have the different types of addressing mode: direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and implied addressing mode. So this is a direct addressing mode. So direct addressing mode, the address contains operand within the instruction. So the operand is specified in the instruction. If you take the examples of load A, that is LDA 2600, in this we have the address of the content which is stored in the 2600, which is moved to that is load to accumulator. So the operand is specified within the instruction. If you take the in 05H, that is in 05 H specified in the specified for hexadecimal notification, that is 5. If you converted the 5 into binary, you'll get the binary value that is going to connect with the that is if you want to connect with the switches. If you want to use switches, you can use in instruction, and if you want to control led, you can use out. Whatever the value you given in the out, that is 07 hash, it converted into binary. Based on the binary value 0101, the led will be on and off. Whereas in the in, the switches we can operate on and off based on the value you have given in the instruction. In the STA instruction, that is 2700H, that is 2700H addressed, and the content of the 2700H will move to store to accumulator. Whereas in the jump instruction, directly jump to the 8000C, that is 800C address. In the register addressing mode, the operand will be present in the microprocessor register itself. If you take the example of move A comma B, the content of the B will move to the A, and add B, it states that the accumulator and the B register will add, and the result will be stored into the A register. Whereas in the subtract C, the once it instruction will executed, the output will be stored in the A, that is A minus C. After executing this instruction, A will be subtracted by C, sorry, C will be subtracted by A, and the result will be stored in A. This is a register indirect addressing mode. The operands are present in the memory, and the address of the memory location is present in the register pair. So this is also called as an indirect addressing mode. So if you take the example of move A comma M, here M indicate that the HL register pair. the content of the HL will move to the A, and whereas in the add M, so the accumulator will add with the M, that is HL pair, and whereas in the load A indirect B, so the B value indirectly move to the load to the accumulator. In the immediate addressing mode, the operand and the data are specified within the instruction itself. So immediately we can get the data from the instruction itself, and it has an operand rather than the address field. So MUI A comma 25H. In this example, the immediately 25, that is the value of 25 will move to the A, and ADI 36H. So immediately the accumulator value will added with a 36, and result will be stored in the accumulator, and load immediately, that is H with 9000 H. So in the content of 9000 H value will be added with the H, and the result will be loaded. In this implied addressing mode, the operations are performed by the accumulator alone. These are the machine control instructions. The operands are implicitly mentioned in the instruction. So if you take the example of compare accumulator and rotate left with, so everything defaultly operated in the accumulator, and whereas in the NOP, that is no operation, and halt is it will be stop the instruction flow, that is program flow. These are the advantages of addressing modes in 8085. First one is improved code flexibility. So it allows the programmer to choose how the operands are fetched via memory register in. The next one is the efficient memory usage. Using the indirect addressing helps minimize the memory usage, especially in the loops and arrays. While using loops and arrays, faster execution, the register implied addressing modes provides faster instruction execution compared to the memory access. If you take the implied addressing mode, we have seen the examples that will faster instruction execution. And versatile programming, in this mode supports a different data access strategies, that is direct, indirect, immediate. So everything we can do in the modes of addressing. And last one is simplified assembly programming. So clear distinction of operand types makes the programming more structured and reliable. Thank you all. Thank you for watching.